A binary tree can be used for many different things, and one of the classic things that it's used for is a binary search tree. And the key to a binary search tree is that when you insert the elements, you insert them in a particular order, not just in the same positions as the array, but based on how they compare to the nodes that are already in the tree. Now, when we're first starting out, we'll insert the 5 as the root node. But when we insert the 9, we compare it to the 5 and say, is it bigger or smaller? If it's bigger, it's going to slide to the right and occupy the next available slot. Well, the 3 compares to the 5 and it slides to the left because it's smaller. Now, the 4 still compares to the 5 and says, I'm less than the 5, but then it reaches the 3 and says, okay, I've got to be greater than the 3, so I slide to the right. The 6 is greater than the 5, slides to the 9, less than the 9, so it slides to the left of the 9. The 2 is going to slide left again, and settle right there. The 7 is going to be 5, go to the right, 9, go to the left, 6, go to the right. Now, do the next 3 and see if you can figure out where they go. All right, let's do the 1. The 1 goes left, left, left again. The 8 goes right, left, right, right. And the 5, that's interesting. It's a tie. So what do you do with ties? Well, you agree that you're going to allow ties to live in the tree, and a tie is going to go to the left in this scenario. It depends on which way you want to go, but most of the time ties go to the left. So we go to the left, and this one's going to go to the right, and this will go to the right. So the 5 is going to live right there. Now, the first thing you should understand about this is not a full or a complete tree. And that's the nature of binary search trees. They want to be balanced, but they're not going to be full or complete, and it doesn't really matter. To traverse these, we're going to do the same thing we did before. So let's go with red for preorder. And remember, preorder is touch left. So it's going to be the 5 first, then the 3, then the 2, then the 1. Now the next preorder, the next touch left, is going to be the 4. Then it's the 5. Then we go up and just imagine the traversal. 9 is the next one we touch. 6 and 7 and 8 to finish up. So this would be the pre-order traversal. Now let's do the in-order traversal. Remember, in order is touch middle. So we still go up to here and imagine the full traversal. What is the first node we touch in the middle? And that would be the 1. And then it's the 2 and the 3. And then it's the 4 and the 5. And then it's the 5 again. And then it's going to be the 6, the 7, and then the 8. And finally, the 9. Now, if you look carefully in a binary search tree, the in-order traversal is in order. That's exactly the nature of it. So that's one way to check to make sure your binary search tree was built correctly. Are the elements in order when you do an in-order traversal? For the post-order traversal, remember it's touch right. So again, we start at the full traversal and go all the way down until we touch the first node on the right, which would be the 1, followed by the 2, and then we circle around to the 5. So 1, 2, 5. The next is 4. Now you finish, and I'll wait. Okay, next would be the 3. And then you go all the way down here. Remember, you can't cross any branches. And then 8, 7, 6, and then 9, and finally 5. So that is the post-order traversal when you do a binary search tree.